Fairly simple still? Yeah, I would think so, right? All right, before we get into this, I want to pause our notes here. On your Inspires, here's what I want you guys to do. I want you to create a new page, or rather a new document. So hit the home button. I want you to create a new geometry document. Fine. So where do we find the largest angle on the longest side?
Opposite.
They're opposites. Where would you find the smallest or the shortest side? Shortest side is always going to be where? Caitlin?
Opposite the smallest angle.
Opposite the smallest angle. So we can actually rank our sides. We might not know their actual values, but we can rank them based on their angle measures. And that's kind of what the notes was talking about there in that last page. So if we come back to here, the triangle inequality theorem. All it really states, this is what you need to write down, so I'm not going to write it down, so you need to listen very closely. All the triangle angle inequality theorem says is that the largest angle is opposite of the longest side. Largest angle is opposite of the longest side. So this is the new theorem. So that's supposed to bring right into the angle inequality theorem. The largest angle is opposite of the longest side. So we look at our example. We have triangle DEF. And I'm asking you to then list the angles in increasing order from least to greatest. So Matt, where is my smallest angle? If we're looking at triangle DEF, where would you find my smallest angle? Angle D or, well, which one's the smallest? Why is that? So which, alright, so actually it's 8 on the other side. So which one is smaller, 5 or 8? So which angle is opposite of EF? D. So which one's your smallest angle? Angle D is your smallest angle. Okay, what's your next smallest angle? Victoria? Angle F. And then finally, your largest angle? It's going to be angle E. Okay, now on the next problem, you're being asked to look at things a little bit different here. You might not be able to copy down the whole diagram. So I want to make sure we discuss this for you guys to kind of focus. If you want to compare angle R with angle VSU, so VSU, so we want to compare it to this angle here, you need to make sure that you're looking at it as part of the same triangle. All right, we can't really compare these in two different triangles. We're going to compare them within the same triangle. So what triangle has angle R and angle VSU? Sorry? RUS. So let's highlight that. So RUS. We're looking inside our yellow triangle. And all I'm asking you to do here is to compare the relative size of angle R and the size of VSU. So, are they equal? Which one's greater? Which one's less? Because when we're looking up here, we have angle R. What side is opposite of angle R? 35. How does that compare to the opposite side of angle VSU? 24. So which one has a larger angle? R. Therefore, angle R is greater than angle BSU. That's it. Okay, that's all it's asking you to do. Now, guys, this is kind of a two-way street. If the largest angle is opposite of the longest side, flip that around and use it the other way. The longest side is opposite of what? Largest angle, right? And so you can go both ways. So you can list your sides based on your angles or list your angles based on the sides. Okay. That's it for, oh, I shouldn't say that. There's actually one more thing I want to talk about. This is one of those things that's not really necessary to know, but it's worth knowing. And you might see it on the homework. Not so much on the test, but you might see it on the homework. And the first time I saw it, I thought it was kind of a crazy question. If I give you three lengths, is the triangle acute, obtuse, or right? Well, that's kind of crazy. How would you know that without actually constructing the triangle? Well, hopefully you guys tell me. How would I know if three lengths make a right triangle? What would have to be true? It would have to be a 90-degree angle. What's something we already used where we know it's a right triangle and we just say something about the side lengths? Think of the Pythagorean theorem. Here you go. So if it is right, then a squared plus b squared equals c squared. That's if a squared plus b squared is equal to c squared. Then it's a right triangle. And then you can actually determine if it's an acute or obtuse. Simply by comparing a squared plus b squared, so that sum of the squares, with the square of the hypotenuse. If the sum is greater than the square of the hypotenuse, it's an acute angle. If the sum is less than, then it's not an obtuse angle. That's it. Alright, that's all the information you guys need for tonight. So you do have a homework assignment waiting for you on Math Excel. I might have to verify that one. I'm pretty sure it's there. And you will need to also do a homework challenge problem. Okay. And then basically the rest of the class is yours to work. Not to surf the web. Not to get on Facebook or Twitter or anything else.